Happy Friday if you're watching this on Friday, but if you decided that I want a free Friday for math, then maybe you're watching this on Thursday, and that's perfectly okay too. Or you didn't do math this week. What is happening? Are you gonna work now? Come on, little buddy. Okay. Maybe if I go slower? There we go. We made it. I have no idea what I was saying before I got distracted. Oh, if you're watching this on Thursday, happy Thursday. Maybe you got a free Friday. Maybe you're doing this on Sunday in a sweaty panic. Like, I have to do all of this stuff before class on Monday because Miss Coppin's taking for a grade. Then I'm sorry if you have the sweaty pit action on Sunday night. Anywho, how we doing? You can't answer me, but I'll probably ask on Monday. This is your last task of the week. All you have to do is follow along with me for day 2 of these notes, fill in your notes, and then I'll check on Monday and grade them to make sure that you did them, along with everything else that you have done as well. So, where we ended up yesterday, in day 1, is we found a wonderful midpoint formula that every single time will work, no matter what values for x and y you plug in. So that's something that we will make sure that we practice with our homework for lesson 6, but I want to make sure we're in class, we understand the formula, understand how to use it, maybe do an example or 2 together, and then you can try some on your own. But where we're at now, a question is, how is finding the midpoint similar to finding the average of 2 numbers? This is where I'd ask you, how do you find the average of 2 numbers? But you're not here to tell me, so I'm going to assume that I heard back, oh, well, you just kind of add up all the numbers and divide by the number of numbers, if you remember talking about that. Add up all the numbers, divide by the number of numbers is how you find average. Well, if we go back to our formula, which I don't have written down anymore, but it was the x1 plus x2 over 2, right? You add up the 2 numbers and you divide by the number. There's 2 of them. Divide by 2. So you're kind of finding the average, right? The direct center of those 2. That would be the midpoint. What a cool connection. Isn't math exciting? This is where you're probably rolling your eyes at home. It's fine. I'll pretend like you're smiling. So our next little task, our last one really, last little bit, is that they're doing a new area in the garden and they want it to be a flower garden instead of a vegetable garden. So Malik's parents have the idea that part of the garden should contain a big rose bush and the rest will be petunias. So they want this section with the other flowers to be twice as big as the one with the rose bush. So instead of being perfectly equal, we have like twice the distance in petunias and then one little small section of a rose bush. And we have to figure out if the stakes are on the endpoints of 1, 5, and 4, 11. So again, if you need to go back to your original, it's on that picture, on the very front of your notes. But we'll look at a close-up in 1 second. Malik's dad says we need a stake that marks the end of the rose garden. Okay, so here are our stakes right now. And it's kind of a blow-up of the picture that you had before. But, sorry, I don't know why this picture is all very funky in the middle of this page. But these are the 2 ends, and essentially, he wants the rose bush one to be closer to the 1, 5 point. So we have to remember that one section is 2 times as big as the other. So essentially, think of it like 2/3 of the way. Right? Kind of like if you have like 1/3 and then 2 other thirds, that makes sense. So there's a few ways to think of it. I think the easiest way to think of it is to do the same little thing that I did first, is I make little triangles. Oh my. Kind of using the slope. Oh, I'm so bad. There we go. And essentially, they're all going up 2 over 1, up 2 over 1. I'm going to erase this business and try again, because that was terrible. Okay. So we need it kind of like 2/3 of the way away from our top stake. So conveniently, if I take 1 triangle this way, and then 2 triangles down from the top, this distance is 2 times 1. And 1 times 2 is 2. So this point here, which is at 2, 7, that is where the stake should go. That's kind of how I thought about it. So the stake should be at 2, 7. So it's kind of like one out of 3 triangles away. So kind of same thing here is they only have one more set of stakes to put in their wonderful backyard. And this time the end stakes are the ones shown here. So a -8, 5 and 2, -10. So a little bit longer of a distance away. The pen's gonna start acting up. There we go. And then another stake needs to be placed that partitions it into a ratio of 2 to 3. So my thought is like 2 triangles on one side, 3 triangles on the other. See if we can get that to work, because that's what makes the most sense to me. The stake needs to be closer to the stake at the top. So we need it to be 2 away from that guy, 3 triangles away from the other. Fingers crossed. Let's hope it works out. So I look for where they cross perfectly in the corner of the box, all the way down, and I make a little triangle. So down 3 over 2, down 3 over 2, down 3 over 2, all the way down. Can we make it? Who's this guy? So I'm 2 triangles away from the top and 3 from the bottom. I sure can. So that would be where my stake went. I have 2 triangles to 3 triangles. Closer to the top guy. Closer to -8, 5, it says. That point is at -4, comma, -1. -4, -1. So again, it is 2 triangles away from our -8, 5 and 3 triangles from our 2, -10, which makes that ratio 2 to 3. There is a big fancy formula to figure out partitions and being able to tell the distance of being 2 to 3. But if I were to make you look or try to see 2/3 of the way, I would think of it like that. Think of it like, can I have 2 triangles to 3 triangles? Or can I make them bigger and maybe go 1 to 1.5 or something? You know, if I make it some big triangles happening. Like if I make it a big triangle and then it'd be 1.5. You know, like something like that. Maybe that'd be easier for you to see than to do the big fancy formula. But now that we have our midpoints and we talked about, you know, how we can go part ways, we're going to do our little takeaways. So to find the midpoint, here's the big fancy formula that you'll need to know. And my pen stopped working at a wonderful time. There we go. So our midpoint, we take our 2 x's, x1 plus x2 over 2. And then we add up our 2 y's, y1 plus y2 over 2. There's our midpoint formula. Anytime we want to find a midpoint, here's our endpoints, the x1, y1, and x2, y2 that we used here. Again, we'll practice how to use it, and you'll say, oh, that makes sense. There's just a lot of letters right now. For this next bit, essentially for my illustration, I'm going to write it over here. You have space. But I kind of just wanted to look at, I don't know why, hold on, I don't know why I did that. Go away. Okay, the whole thing will go away, that's cool. If here's like our grid, and then we have these, our 2 endpoints. We kind of made like little ladders. And then we said, if I need to do 2/3 of the way, like this is 2, and this is 1, so this would be a 2 to 1 ratio. Or 1 to 2, depending on if you're going from whichever side. So that's kind of how I think about it, illustration-wise. Essentially, we just need to know to look at our triangles made by using our slope. And then, like for an example, 2 to 3, means 2 triangles on one side of our point and 3 triangles on the other. It's essentially what we're using when it's not perfectly halfway. When we're not finding the direct middle, the midpoint, we can use this formula every time it's directly in the middle, but when we have some random partitions, then that's when we can just kind of use the triangle rule. And just, if you don't remember what a midpoint is, obviously the midpoint is right in the middle. Divides directly into 2 parts. Okay, our retrieval is kind of review, hopefully. I'm going to have to pause and I'll finish the review in 1 second.